All right. Well, welcome to our second to last module lesson, remote learning lesson. After this week, we will be working. This is the last week of new stuff. So, not really new stuff, but anything before the final, because our final, Marlene, did you get an email telling you yet when the final is?
I think I did, yeah.
Yeah, there should be a whole schedule that all of you have received, the entire class. It tells you every day when your finals are, what day, what the format is. If you haven't gotten it today, everyone should receive it. So our final assessment, we won't have one this week actually, but we will have one next Thursday. So this week we did Ed puzzle lessons, which most of you had done. We didn't do the virtual lesson, but on Thursday or Tuesday I did have the office hours. Today we'll do the virtual lesson and try to review stuff that we kind of did before, but not too intense. And tomorrow I'll probably give you today after the virtual lesson, you will have some homework to do, not too many problems. And then we'll do it again next week, and then we'll have the post assessment on Thursday of next week, and then that'll be it for all of our new stuff until you have the finals. Any questions on that? Anyone who's here, or I guess just our fearless partner in crime here always with me is Marlene. You good with all that?
Yep.
Cool. All right, so this week, remember, like, we're gonna do FOIL method again. It's gonna be not the diamond method, but I'm gonna call the box method this time. I know we've done some of this before, but let's look back at like when we're talking about combining like terms just very quickly. So today you'll be able to multiply a monomial and polynomial, multiply two polynomials using the FOIL method, the box method, and distributive property, and then use patterns to multiply special binomials. So we're gonna try and go through this step by step. We kind of did it a few weeks ago, but let's see where it goes. So if I were gonna simplify the following expression, since I only have Marlene here with me, what is x times x?
That is x squared.
Exactly right, because x times x means what we have is x squared, whereas x plus x is what?
2x.
Exactly. So if we were going to add that more, what would be, if we were multiplying these two expressions, you've got 4x squared times 2x squared. Gets a little bit more tricky.
6x to the fourth power.
Not 6. What's 4 times 2?
Oh, 8.
Yeah. So what we have is 4 times 2. Hold on. I'm trying to add on here. Okay. Yeah, so it'd be 8x, and then when we're multiplying, so it's going to be x to the fourth. Is that what you said?
Yeah.
Cool. And then if we're doing it when we're just adding and subtracting, you have to make sure that the x squared are both there. Those are the like terms. So what's 4x squared minus 2x squared?
2x to the fourth.
Nope, you don't even have to change the exponents. It's just 2x squared. When you're adding and subtracting, the exponents stay the same. When we're multiplying, that's when they're going to change.
Alright.
Okay, great. So if we were also going to, like, what is the greatest common factor between these terms? Like if I was going to take the biggest number and letter that would come out of both of these, like over here, what could I take out of both that I could then write a new equation with?
8.
Good, so I can divide both of these numbers by 8. And if I took 8 out, what would then be in the parentheses that would then make this a true statement?
It would be 2x.
Good.
And
minus?
-1.
Yep, just -1 works perfect. So what we did was took out the 8, because that goes 8 out of 8 here. So what you left with is 8 divided by 2, and the x stays where it is. 8 times 2x plus 1, and if you did distributive property backward, it would come up with this. So what about down here? What can I take out of 4xy plus 2x?
2x.
Good. Yeah, not just 2, but 2x. And then the new equation, so what's left? I've got a 2.
2y.
Very good. Plus 1. And that's it. So when we're doing, this one's a little bit more complicated up here, and I'll come back to that next week, I think, because I want to get back and didn't really copy correctly. But when we're factoring, this is going to come up when you're trying to figure out how to factor out binomials, or trinomials. So after we get to, let's look at adding these monomials though too, because you want to be able to combine all the like terms. So if I combine all of my like terms here and created a whole new simplified problem, what would it be? I'm going to remove all the parentheses first. So Marlene, now I've got 9y minus 7x plus 15a minus 3y plus 8x minus 8a. All right, so let's combine the y's first. So we got 9y minus 3y. And what is that going to equal?
6y.
All right, 6y. So the y's are combined. So we got negative 7x and we've got positive 8x. What do you think we're going to be left with?
1x.
Good. So negative 7 plus 8 is 1. So we can just leave it as plus x. And then we've got 15a minus 8a, and that equals what?
7a.
Yep, positive 7a. So now all the things are simplified. They're all combined, and that's where we finish that. That's where the problem is done. Okay?
Okay.
Great. Let's see if anyone, nope, okay. You can group your like terms, and as we came up with, there you go, 6y plus x plus 7a. What about here? Now we're going to use, oh, let me take a step back. If we use a distributive property, so what you want to do would be multiplying everything in the first two, like here, 2 times 5 plus 8, and then 3 times 5x plus 8. So if you did all that, what do you think? We take this one out, we take this one out. It's kind of the same idea as the FOIL method, which we're going to introduce again, but this is the distributive property method. So you can take the first variable here, 2x, and multiply it by everything in the other parentheses. Then you take the second variable, which is 3, and multiply that by everything in the rest of the parentheses too. So if we multiply this out, what's 2x times 5x?
That's 10x squared.
10x squared. I'm going to do a little, let me see if I can make that look better, but all right, we can just leave it as a little 2 there. That's 2x, 10x squared, and then plus, what's 2x times 8?
16x.
Good. Now in the next one, we've got 3 times 5x.
That's 15x.
Perfect. And then plus 3 times 8.
24.
Good. So now we've distributed everything out. All we have to do is combine our like terms to come up with our final simplification. So we're going to have 2x squared is going to stay the same. And now you have to combine 16x plus 15x, which equals what?
31.
31x, and then plus 24. And that's it. So you can use the distributive property. So you multiply everything in one parentheses up here, take the first variables, multiply it by the next part, and then take the second variable and multiply it by that, which is a pretty easy way to do it if you are really good with distributive property and you do it in the correct manner. So that's one way we can do this kind of problems. Another way, which many of you, so here you go, we got 10x squared, combine the like terms, and you come up with 10x squared plus 31x plus 24. Awesome. So we're going to be able to do that in many different ways. So we're going to do 3 different forms. So that the way we did the last one was using distributive property. That looks just like that. And now we're going to do the FOIL method. Have you heard of FOIL before, Marlene?
Yeah.
You kind of introduced it. It means first, outside, inside, last. So here, if we had a problem, what is my first term?
The first terms are the x's.
Good. So I got x times x. My outer terms,
Outer terms are the x and the 3.
x times 3. My inner terms, good.
The inner terms are -4 and x.
-4 times x. And our last two terms,
-4 and +3.
good. So those are the four, that's the main FOIL. That's what it means. You're going to be multiplying them. It's the same, you'll come up with the same answer as you did if you did distributive property. But here you have x, so x times x. If we were going to write that out, x times x equals x
squared.
That x2 means x squared for everyone following along at home. Now the outside terms is x times 3. So what we've got is plus 3x. And then the inner terms are -4 times x. So what we have is -4x. And then our last two, which is -3 times 4, is what?
-12.
Good. So then we combine the like terms, and our final answer is x squared minus x minus 12. Okay?
Okay.
Great. Let's try a couple more, and then we'll see the next method. How would you do this one if you explained it for me, Marlene? This is kind of a special case scenario. So let's try the FOIL method here, and you tell me what I would do first.
Okay. So first we have to multiply the x's.
Good. So our first is x and x. So what we've got is x what?
X squared.
X times x is always x squared. Very good. Next.
Then it's x times 5.
Yep, x and +5. So 5 on the two outer ones, 5 times x, so that's plus 5x. The inner ones will equal what?
So that's -5 times x, -5.
And then -5 times 5.
-25.
Awesome. So when we combine our like terms, what are we going to be left with though?
X squared plus 1.
No, you got plus 5x minus 5x equals what?
Oh, that's 0.
Yeah, because we're just combining 5 minus 5. So there's going to be nothing there. All I'm going to be left with is x squared minus 25. So that's going to be a pattern of problems that you may see. Like if you'll have one that's like, if we're doing it backwards and we're trying to factor, if you see one that says x squared minus 25, you know that the two numbers in the middle have to be the same, but they're going to be opposite signs. So we'll try a couple more of those in a little while. So it can get more complicated too. Like it's not just going to be x times x, it could be 3x times 5x to the third power, and that can even be a thing. So if we did something like that, how do you think this one would come out? I'm multiplying 3x times 5x to the third power. And if we remember our exponent rules, how do you think if we multiply our first two product, what's 3x times 5x to the third? What do you think that's going to look like?
15x.
Good.
Uh,
And remember, when we're multiplying exponents, we're just adding them. So x times x to the third is x to the fourth. Okay?
Uh-huh.
All right. And then we're going to multiply our outer one. So what's 3x? What's 3x times 2?
3x times 2 is 6x.
Good. And then what's -5 times 5x to the third?
-25x.
To the third, exactly. the x is just going to stay the same. And then the last one is -5 times 2, which is just -10. So what I've got here, I know it looks a little funky, but 15x to the fourth plus 6x minus 25x to the third minus 10, those don't all combine. But we want to put them in order from the highest exponent to the lowest exponent. So I'm going to put it like 15x to the fourth minus 25x to the third plus 6x minus 10. So this might be one of the more complicated ones when we get to, but just know that the FOIL method would work for any of these. Okay? Great. Want to try this last one here before we do the box method. All right. So what's 7p squared? Our first terms is 7p times 3p. 7p squared times 3p is going to equal what when we multiply them?
21p to the third.
Yep. And then 7p squared minus 4 times -4, sorry. Would be negative what?
Negative 28p to the second.
Awesome. And then we've got -2 times 3p, which is just going to be 6p. And then -2 times -4 is going to equal +8. So again, we might have more, we might not combine all the like terms in the middle. If we can't, then we just leave it like that and you're done. Cool. All right, so we've done distributive, we've done FOIL, and the last one is called the box method, which you may like as well. So let's look at this one. So let's say you've got 3x minus 5 times 5x plus 2. What we're going to take is our terms, our first terms. You have the top two. Here's 3x minus 5, 3x minus 5 in your top box. Then you got 5x plus 2, so you put 5x and +2 in your second boxes. Next step, what do you think is going to be our step?
Multiplying the two numbers into the box.
Yeah. So what's 3x times 5x?
15x squared.
Yeah. So you're going to have 15x squared there. And you've got 5x, and then bring down -5. So what's 5x times -5?
Negative 25x.
Perfect. And now you've got 3x plus 2. So that's going to be 6x. And our last one is -5 times +2, which is -10. So again, I don't know if you like this. It's kind of like a Punnett square. I don't know how much stuff you've taken in biology or chemistry or anything like that. But this is another good way. Like you just multiply here, multiply every box by itself, and then combine our like terms. And what would our final answer be?
It would be.
So we got 15x squared
minus 25x.
Yep. Plus 6x.
Plus 6x minus 10.
And then when those are combined all the way out, we've got 15x squared minus 19x minus 10. So I don't know if you like that. Do you like that method too?
Yeah.
It's a little more straightforward for some people. I feel like it's more visual and you might not mess up certain things, but I think it's a great method too. So if you like it, try it. We'll do some problems. I'm going to give you some later after I post this video lesson online. There's another example here though. So if we got it, what is the same thing? We did exactly how we did it before. We got the first terms, combined them, and they got 15x squared. Perfect. All right. So if you want to go through this on your own, we're just showing you the same terms that we did here and just filling in the boxes as we go along. The last step is coming up with factors. We did this a little before. So when you're trying to go from one direction to the other, we can figure out how to get x. We can go from the parentheses, but can we go backwards? So one of the ways we want to do this is to solve for greatest common factors and figuring out what numbers, again, will multiply to equal this number, but then we'll add together to equal this number. So there's a few different ways we did this before. I'm going to switch screens here, actually, I think, Marlene, because we did these before, and I also wanted to show you. I'm switching pages, and then I'll reshare. All right, so I gave you this homework a while ago. Remember this?
Yeah.
So it's the same basic idea here that we need to, if we're going to go from one direction, if we can do the FOIL method to figure out how to multiply them, we need to do the opposite to figure out how to factor them. So one of the ways they do it is you always look at the product is the final number there. So you have to multiply, let's say we had a binomial that we were trying to multiply out and using the factor method. This way we want to do it the other way. So I want to figure out what factors are going to equal to fill it out. So what numbers do you think I could put in here? Like what are some numbers that multiply out to equal, to equal 36? So let's think about it. I can do 9 times 4. I could do -9 times -4. What else? I could do 12 times 3. And don't forget the negatives, guys, because that could also come up. -12 times -3. Can you think of anything else? To equal 36?
6 times 6.
Good. 6 times 6. Or -6 times -6. And well, don't forget the last one, which is 36 and 1. Or 1 and -36. All right, so now we're looking at this. Which of these numbers could I add them together to equal -13? Like this -9 plus 4 equal 13? Not -13, no.
So it would be
-9, right.
negative.
Right, so you got -9 minus 4, and -9 minus 4 equals -13, but -9 times 4 equals +13. So what we figured out, and based on these numbers, I'm going to take them over there. So what we figured out is if I had 2 now parentheses, if I rewrote that problem, what would it look like?
It would be x minus 9 parentheses x minus 4.
Exactly. So once you figure out the numbers here, the products, you got your ordered pair over here, and then you just plug it into the formula, x times -9, and then x minus 9 times x minus 4. We'll do one more of those, and we'll probably continue going over this this week and next week. So check Edpuzzle things as well. Tonight I'm going to probably give you a homework that's going to cover most of it. So we'll see how it goes. What about if I had -32 and -3? What factors? What can we multiply to equal -32? So we've got 8
times
-4. Yep. Or -4 times 8. Or what else? You got 16 times 2. I mean -2. Or -16 times +2. And again, -32 and 1. Or 1 times -32. Are there any others you can think of?
Not that I can think of now.
Probably, yeah. Okay, this one, that number in the middle, that middle number, they put as a typo, that should be -4, not -3. So if that sum is -4, which of these numbers would work? 8 and positive, 8 minus 4, or, sorry, I wrote that wrong, 4 and -8.
4 times -8.
Good. So what we'd have then up here at the top would be x, if we filled it out as an equation, it would be x plus 4 times x minus 8. And that would be it. So you go through the factors and you figure out your products. That's the first step. You have to figure out what the product is before you can figure out what the sum is going to be. So I'm going to erase this because I want to go back to, do you have any questions about that, Marlene?
Nope.
Great. Those of you who are not in on this lesson, please, if you have questions, reach out. The Ed puzzles show you the same videos, and it should show you the same ways of doing things that I did. If you want to ask questions, please feel free. I only had a couple of people come to office hours. I can set up extra ones if you would like as well. This was the 3 Ed puzzles that were due this week. Most of you have already done them. If you haven't, go back and check and try to, because it really does show a pretty good representation of the kind of questions and lessons that we'll be doing. I'm going to, again, here's another way to do the box method, which we can do again next week, and independent practice, but we're kind of running out of time here. So I wanted to wrap it up. Tell you, did you have any questions, Marlene, about anything today? Any questions about the scheduling, anything at all?
I do have a question about our final.
Okay.
So is the final going to be on Go Formative?
Yeah. That's the best way that we've figured to do it. And since you've been getting used to doing it that way, I feel like it's.
So it's going to be something similar to our post assessments?
Yeah, it'll look very, very, very similar to those. Like there'll be multiple choice questions, open-ended questions, graph. It'll cover everything that we've covered. So it'll be like, it's not going to take any longer than an hour is what we're planning for. And you won't be able to do it late. So you'll have to turn it in on the day that it's due, which is, I believe, June 1st.
Yeah, I think so.
I think that's what it is. And so I'll be holding next week. Mr. Grady and I actually will both be doing it. We'll have 2 different review sessions, not next week, but the week after for the final. So those are on the email that you received as well. So you can check that out. There should be a schedule for you there for all your teachers as well. They'll all be holding, most of them will be holding office hours as well. Next week, I'm going to have the virtual lesson again on Tuesday as usual. So we'll be back to that schedule, and I'll send everyone the invite. So come ask questions. The final assessment for this work, polynomials, box method, distributive, FOIL, all the things that we're going to go over the next couple of days. The assessment, there won't be a pre-assessment. There will be a post-assessment, though, on Thursday, a week from today. Okay? All right. So thank you very much for coming. And I hope you have a great day. And I will post the assignment on Google Classroom a little later, and it won't be due until tomorrow at some point. Okay? All right. Have a good day. Thank you, Marlene.
You too. Bye, Mr. Hood.
Bye.